y'all, how you doing? Hopefully everybody's doing well. Back for some more physics. I was thinking of what I should do right now, and I think I'm going to continue reading classical in preparation for the upcoming homework and the upcoming exam. So we left off on infinitesimal rotations on page 167. So we'll continue there. There we go. And be sure to like, subscribe if you haven't. Offer tutoring. You can see some information there. You can go to the website at the top, go to the STEM page. Contact me and let me know if you're interested. Anything up to undergraduate physics, astronomy, and math. So we have equation 4.72, 4.75. Based upon this image here. The idea is R minus R is this purple line between these two. So this is R prime, this is regular R. We have R prime minus R is dr, the purple line going across, which is R cross d theta, theta. R cross d omega. Okay. So the limit, the cross product of R and d omega would be like that, which makes sense. Yeah, that's correct. So to be R then d omega. Using the right hand rule, it'd be R then d omega, and then the fingers are pointing in that direction. So that seems good. Comparison with equation 4.72 indicates that d omega is indeed a vector and is determined by so adjust my template a bit. I guess y'all can see the template. Equation 4.75 can of course be derived directly without recourse to the finite rotation formula. Consider, in its active sense, the infinitesimal coordinate transformation corresponds to a rotation of a vector r clockwise toward an angle d theta, that's the image I drew, about the axis of rotation, a situation that is depicted in the figure 411. That's what I drew there. Thus shows that the magnitude, direction, and sense b vector r is the same as that predicted by equation 4.75. I actually don't see how they got that from the derivation. So the infinite rotation. Okay, I forgot. This matrix is the same thing as R across the theta, like the form of the result is in the form of a cross product. And we get this from multiplying the x vector into there. And we get that vector. Yeah, this one. See if I can, I'll arrange some time to speak with my professor. I actually have a pretty busy schedule on Monday too. I'll be able to make it Monday. Looking over everything. Yeah. Yeah. I mean, I can make it sometime on Monday. Maybe 3 o'clock, 2 o'clock, 2:30. So I'll put that on my calendar now. Make sure I don't forget. All right. Where does this come from again? The epsilon. Oh, decimal axis rotation. Okay, that's right. That's right. So this came from plugging in. We covered this in class yesterday. I believe it was yesterday. And I had realized myself that this cosine, uh, actually, I mean, I started to consider it, but they said it later. I wish they would have said it when the question was brought up. But approximating a very small angle, cosine of 0 is 1, and sine of a small angle is the angle. Right, keep going. The figure. uh, So I think this is still one detail I didn't get yet. So the magnitude of dr to the first order and d phi is from the figure dr equals the magnitude of d r. Right? Sometimes my little click thing doesn't work properly. Equals r sine theta d phi. This is the case from this image. dr is going across. We have r sine theta. Okay. Sine theta this. We have a circle R, we have an angle theta, and S, we have S equals R theta. So it seems like this is what they're doing here. R sine theta is R, and d phi is theta. Because this R sine theta is going to output this line here. So that moving through an angle d phi still doesn't seem to work. Right, keep going. And the direction dr is in this limit perpendicular to both r and d theta. Doesn't make a little bit of sense because I was thinking of how r sine theta is going to be shorter than r since it's this vertical area here. But dr is shorter than the actual arc length. Dr smaller than s arc length. I think that's what it is. Yeah, okay. Because it's a cross product, it has to be perpendicular to both. Finally, the sense of dr is in the direction a right-hand screw. Finally, the sense of dr is in the direction a right-hand screw advances as r is turned into d omega. Figure 411 thus shows that in magnitude, direction, and sense, dr is the same as that predicted by equation 4.75. The transformation properties of d omega, as defined by equation 4.76, are still to be discussed. As is well known from elementary vector algebra, there are two kinds of vectors in regard to transformation properties under an inversion. Vectors that transform according to equation 4.72 are known as polar vectors. Under a three-dimensional inversion, it's a little bit smaller template here. equals components are Sij equals negative Kronecker delta Ij. Okay, so when I equals j is 1, otherwise it's 0, there's a negative in the front. That makes sense. All components of a polar vector change sign. On the other hand, the components of actual vectors or pseudo-vectors do not change sign under inversion. Actual vectors is a pseudo-vector. The cross product of two polar vectors is the actual vector. The components of the vector cross product are given as customary by the definition. Components of D and F change sign under inversion. Hence, those of C do not. Many familiar physical quantities are actual vectors, such as the angular momentum. The magnetic field intensity. The transformation law for an actual vector is of the form equation 4.74. Proper orthogonal transformations, actual and polar vectors are indistinguishable, but for improper transformations, i.e. involving inversion, the determinant equals 1. The two types of vectors behave differently. Another way to explain this property is to define a parity operator P. The operator P performs the inversion if F is a scalar, V a polar vector, and V prime an actual vector. You see this is obvious, but let's see how this is obvious. So we have P V dot V complex conjugate. That's going to equal P V dot P V complex conjugate. Rid of PV. Let's see, in the wrong direction. That's P V dot P V star equals negative V dot V star. Equals negative V dot V star. On the passive interpretation of thus V dot V star is a pseudo scalar S star. So because P S S E S. So P V dot V star equals negative V dot V star. V dot V star is a pseudoscalar S star with P S star equals negative S star. And of course, P S S star, right? That makes sense. P S S star equals negative S S star. P S V equals negative S V. P S V equals S V. P times whatever is negative P whatever, unless it's a star. No, even if it is a star. Okay. P S is S. P V star is V star. P V is negative V. So this negative comes from the P V. This negative comes from P star. On the passive interpretation of the transformation, it is easy to see why polar vectors behave as they do under inversion. The vector remains unaffected by the transformation, but the coordinate axes and therefore the components change sign. What then is different for axial vector? For an actual vector, it appears that an actual vector always carries with it a handedness convention, as implied, for example, by the definition of equation 4.77. Got an equal sign? Take a look at the paperwork really fast. The yes equals D star equals D J F K minus F J D K. The definition of a cross product. Actual vector is like a cross product. An inversion, a right-handed coordinate system changes to a left-handed system, and the cyclic order requirement for equation 4.77 applies a similar change for the right-hand screw convention to a left-hand convention. Hence, even though the passive interpretation is an actual change in the direction of the cross product upon inversion. It is clear now why d omega transforms as an actual vector according to 4.74. Algebraically, we see that since both r and dr are in equation 4.75, polar vectors, and n, and therefore d must be actual vectors. For something. Geometrically, the inversion of the coordinates corresponds to the switch from a right-hand screw law to a left-hand screw to define the sense of n. The discussion of the cross product provides an opportunity to introduce a notation that will be most useful on future occasions. The permutation symbol, or Levi-Civita density, right? Defined to be 0 if any two of the indices are equal. And otherwise, either 1 or 0. Try to see where this beeping is coming from. It sticks out. -1 if thus in terms of the permutation symbol 4.77 for the components of a cross product. So I don't know where this beeping is coming from. components of the cross product in E form, but a usual summation convention has been employed, which means that if a certain indices is repeated, it's summed over that indices. So it looks like it's summed over the J indices. The description of rotation presented so far in this chapter, the descriptions of rotation presented so far in this chapter have been developed so that we can represent the orientation of a rigid body. Note that the transformations primarily involve rotation of the coordinate system. The corresponding active interpretation of rotation of a vector in a fixed coordinate system therefore implies a rotation in the opposite direction, i.e. a clockwise sense. But there are many areas of mechanics or physics in general, for that matter, where we are concerned with the effects of rotating the physical system and associated vectors. The connection between invariance of the system under rotation and conservation of angular momentum has already been pointed out. And the footnote says also known interchangeably as the alternating tensor or isotropic tensor of rank 3. Or two transformation from the coordinate system x to a new coordinate system. So the coordinate system changes. By convention, this transformation is considered positive in the clockwise sense. We refer to this as a passive transformation. The change of the coordinate system, object stays the same. The rotation of a body through an angle theta prime. By convention, the rotation is positive in the counterclockwise sense. Before the coordinates, maybe I need to, pretty sure this is coming from this voice chat program somewhere. We need to turn off notifications. Or sounds or something. See what it is. Like it's saying there's messages, but I don't see any messages, so I don't know what they're doing. All right, best we fix that. Before the rotation, the coordinates of points of the body were given by x, y, z. After the rotation, they're given by x prime, y prime, z prime. This is called an active transformation because the physical body moves. In such applications, it is necessary to consider the consequences of rotation of vectors in a usual counterclockwise sense. For reference purposes, a number of rotation formulae given above will be listed here, but for counterclockwise rotation of vectors. All equations and statements from here to the end of this section apply only for such counterclockwise rotation. The rotation formula equation 4.62 becomes The rotation formula 4.62. I'll copy this down. Now equals r cosine 5. So, and the r is the same as cosine 5 plus the corresponding infinitesimal rotation, 4.75, appears as seven five d equals d omega equals d omega cross r equal d phi r equals n phi. Hold up. The antisymmetric matrix of the infinitesimal rotation equation 4.69 69 uh, like that. which equals 0, negative, and 3, and 2, and 3, 0, negative, and 1, and 2, and 1, 0. D5. Because d omega is in d5. That makes sense. N1 are the components of the unit vector. The unit vector is a long axis of rotation, letting dr stand for the infinitesimal rotation r minus r prime. These r prime are is in 4.66 and take the form of a matrix differential equation. All these equations, man. Must be a better way than all the scrolling back and forth on the when they reference the early equations, but think about what that would be. I thought maybe I did some kind of an abbreviation and it should be R, but the step. I guess what they're saying is that this will be this will be in dr d5. That makes sense because this is r prime. The prime is r changed by a certain amount. That's why the axis changes by phi, and that's how it becomes x prime. So that's dr changed by d phi. N is a matrix. This the matrix N, and R is the original vector. Where N is the transpose of the matrix on the right in equation 4.69. elements in j equals epsilon I j k n k. Another useful representation is to write epsilon in equation 4.69 prime as confirm the sum is on this equation here. Epsilon n I n is good so far. And we had 7 prime vi star. I missed that. Ah, it gives you the different symbol in the book. We use CI in America, they use VI star in wherever this international notation is from, unless we have a typo. We know that they do have typos in this book. M1 are the three matrices. Mi are the three matrices. M1 equals 0, 0, 0, 0, 0, negative 1, 0, 1, 0. M2 equals 0, 0, 1, 0, 0, 0, negative 1, 0, 0, and M3 equals 0, negative 1, negative 1, 0, 1, 0, 0, 0, 0, 0. There's 4.79. Matrices Mi are known as the infinitesimal rotation generators. They have the property that their products are J equal minus J is equivalent to the commutation operator. Jumbled here is 480. So that's a commutation. The commutation operator is epsilon ijkmk. The difference between the two matrix products or commutator is also called the Lie bracket or MI. In equation 480 defines the Lie algebra of the rotation group parameterized in terms of the rotation angle. To go further into the group theory of rotation would take us too far afield, but we shall have occasion to refer to these properties of the rotation operation. All right, seems like here's a good time to take a break. Thanks to all who will watch. Make sure you like, subscribe if you haven't. Let me know if you have any questions or comments in the comment section. And also, I'll see you all, if not later, I'll be back tomorrow, definitely next week. See you then.